Namaste children. Today we'll discuss about expressing concentration of solutions. That is, last year we have learned different ways of expressing concentration. You'll be remembering that in the first chapter, molarity, molality, mass percentage, etc. So once again we have the same topic in the 12th standard also. So let us discuss about, or let me remind you about all the concentrations that we learned last year. So first one is expressing the concentration of the solution. What is concentration? The amount of the component present in a definite amount of the solution is called concentration of the solution. Concentration of a solution can be expressed either qualitatively or quantitatively. Qualitative, dilute. You know what is a dilute solution? A dilute solution is a solution that contains a small proportion of solute relative to the solvent. And concentrated solution means a solution that contains a large proportion of solute relative to the solvent. Quantitative is, we have learnt last year, the mass percentage, volume percentage, mass by volume percentage, parts per million, mole fraction, molarity and molality. First we'll discuss about mass percentage. What is mass percentage? 10% of glucose in water by mass is 10 grams of glucose is dissolved in 90 gram, resulting in 100 grams of the solution. Repeating it once again, 10% of glucose in water by mass means 10 grams of glucose is dissolved in 90 grams of water, resulting in 100 grams of the solution. We'll go to the definition of mass percentage. Before that, 10 gram of glucose, that is a solute present in 100 grams of the solution. So the meaning of this is 10 gram of glucose, that is a mass of the solute, is present in 100 grams of the solution. 10% of glucose solution is expressed as 10% glucose by mass is equal to 10 gram of glucose divided by 10 gram of glucose plus 90 gram of water into 100. 10 gram of glucose by 10% glucose by mass is equal to 10 gram of glucose divided by 90 plus 10 becomes 100 into 100. So mass percent is defined as the mass of a component present in 100 mass unit of the solution, that is mass of the solute divided by mass of the solute plus mass of the solvent into 100. So mass of the solute, the denominator part, mass of the solute plus mass of the solvent is the mass of the solution. So mass percentage is defined as the mass of the solute divided by the mass of the solution into 100. Hope it is clear to you all. So mass percent of the solute, as you can see here, it is a fill in the blanks type given to you. You will be knowing it. Mass percentage of the solute is mass of the solute divided by, it is the total mass of the solution into 100. Mass percentage of the solvent would be mass of the solvent, I am putting it here, divided by the total mass of the solution into 100. So if it is solute, if it is the mass percentage of the solute, it is mass of the solute by total mass of the solution into 100. If it is mass percentage of the solvent, it is mass of the solvent divided by total mass of the solution into 100. There is a problem for you. Calculate the mass percent of a solution that is prepared by adding 49.7 grams of NaOH to 480 grams of water. Very simple question. You will be knowing it. You know the solute here is NaOH or sodium hydroxide, and mass of the solute given is 49.7. and mass of the solvent given here is 480 grams. Water is the solvent. So you'll be writing it in your notebook. I think there's a problem given to you. You can, by the time you can start writing. So how to calculate it? The solution here, the mass of the solution is equal to mass of the solute plus mass of the solvent. Mass percentage of solute, as we have learned earlier, reminding it once again, mass of the solute divided by total mass of the solution into 100. Mass percentage of the solvent is equal to mass of the solvent divided by total mass of the solution into 100. Solution of 49.7 grams NaOH. So mass is NaOH, water's mass is 480. So mass of the solution is equal to 49.7 plus 480 becomes 529.7. That is the mass of the solution. Mass percent of NaOH, that is mass percentage of the solute, equal to, it is the mass of the solute divided by the total mass of the solution is 9.38 grams. And mass percent of water, the solvent, we know mass of solvent is water here, so it should be mass of the solvent is 480 divided by the mass of the solution into 100, and it is 90.42%. Children, you can do it and verify the answer. Second problem related to mass percentage. An aqueous solution contains 700 grams of water and 45 grams of sodium hydroxide. What is the percent by mass of sodium hydroxide? A very easy question. It is, first write the equation. Always for doing the problems for equation there is mass, so don't forget to write the formula or the equation. Mass percent of NaOH is equal to mass of NaOH divided by the mass of NaOH, that is a solute, plus mass of the water, which is a solvent, into 100. Substitute in the values, that is all masses must have the same unit. The units should not change in the numerator part and the denominator part. You all know that the unit should be the same. So mass of NaOH is 45 grams. Mass of water is given there. What is it, children? Mass of water is 700 grams. So mass percent of NaOH is 45 divided by 45 plus 700. Very easy. And the answer is 6.04%. Next is volume percentage. What is volume percentage? If you are taking 10% ethanol solution in water, that is 10% ethanol solution in water means ethanol is in the liquid form. 10 ml of ethanol is dissolved in 90 ml of water, resulting in 100 ml of the solution. That is, the solute here is ethanol, solvent is water. So the denominator part is the volume of the solution. Volume of the solution would be volume of the solute plus the volume of the solvent. Volume percentage is defined as the volume of a component present in 100 volume unit of the solution. That is, volume percent of the solute is, we know now, volume of the solute. This is more easier to learn. Volume of the solute divided by volume of the solution into 100. Volume percent of the solvent. Volume percent of the solvent would be volume of the solvent divided by volume of the solution into 100. Solutions containing liquids are expressed in this unit. That is, volume by volume percentage is taken as when the solute and solvent both are liquids. Volume percentage. A small problem. So these problems are also same as that of mass percentage. So it will be more easier for you to do. The question is, find out the volume percentage of ethanol when 10 ml of ethanol is mixed in 190 milliliters of water. A very easy question. I know all of you will be able to do it. We'll go through the answer. Volume of the solute, that is ethanol, is, what is the volume? It is 10 ml. Volume of the solvent, that is 190 ml. Total volume of the solution would be volume of the solute plus volume of the solvent. Volume of the solute is 10, and what is the volume of the solvent? It is 190 ml, which is 200 ml. So the volume percentage of ethanol is volume of the solute, which is 10 ml, divided by volume of the solution into 100. It is 10 divided by 200. Got it here earlier. Into 100. It is 5%. Next way of expressing concentration is mass by volume percentage. Just from this itself it is quite clear. The solute is expressed in mass while the solution is expressed in volume. A unit commonly used in medicine and pharmacy. This is actually used in medicine. While having medicine also, we know a particular solution, most of the medicines are in the colloidal form, which you have learnt also, because it is easily assimilated in our body. So most of the medicines, the solute will be in the solid form, and that will be dissolved in a particular solvent. Another variation on mass percentage concentration is weight by volume percent, or mass by volume percent. This variation measures the amount of the solute in grams but measures the amount of the solution in milliliters. Mass by volume percentage is defined as the mass of the solute dissolved in 100 ml of the solution. So 5% NaCl solution containing, this is quite clear, the solute is sodium chloride, which is mass is given, it is 5 gram, and the solution is in 100 ml of the solution. Mass by volume percentage is equal to mass of the solute divided by volume of the solution into 100. Now we'll do one problem. What is the mass by volume percentage concentration of 250 ml of aqueous sodium chloride solution containing 5 grams of NaCl, which is very easy, it will be very easy for you. Mass by, always don't forget to write the formula or the equation first. Mass by volume percentage is equal to mass of the solute divided by volume of the solution into 100. The sodium chloride mass given is 5 grams. Volume of the solution, what is the volume of the solution? It is solute plus solvent. That is, here the solution is concentration of 250 ml of aqueous sodium chloride solution containing 5 gram of NaCl. So the volume of the solution is 250. And so applying the values in the formula, it is mass of the solute is 5 grams divided by the volume of the solution is given, so it is 250 ml into 100 is 2 gram by 100 ml of the solution. Next, a new way of expressing concentration, which we have not learnt last day, but we have used it in some places. It is parts per million. Now the word itself says how we are going to express the concentration. Parts per million or parts per billion are examples of expressing concentrations by mass. These units turn out to be convenient when the solute concentrations are very small, so almost trace amounts of the solute will be present. ppm or parts per million is defined as the number of part by mass of the solute per million parts by mass of the solution. That is, ppm is defined as the number of part by mass of the solute per million parts by mass of the solution. When you write the equation to be more clear, for example, if a solution has 1 ppm solute, this would mean that 1 gram of the solution would have 1 million gram of the solute. That is the meaning of it. That is, when from the formula it is mass of the solute divided by mass of the solution into 10 raised to 6, not 100, this is not percentage, it is million, so into 10 raised to 6. Mass of the solute divided by mass of the solution into 10 raised to 9 would be parts per billion. So there are 2 parts per million and parts per billion. Next, last year we have learned another way of expressing concentration is mole fraction. Mole fraction is a unit relating some physical properties of solution, say vapor pressure, with the concentration of the solution. This is used in calculations involving gaseous mixtures. We will be learning more about mole fraction and application of mole fraction in the second chapter, that is solution chapter. Mole fraction of a component, that is a component means in a solution there will be a solute and a solvent. So a component in a solution is expressed as, mole fraction of a component in a solution is expressed as, mole fraction of the component X is number of moles of that component divided by total number of moles of all the components. Unit of mole fraction being a ratio is dimensionless. There is no unit. In a binary solution containing 2 components, say A and B, if Na is the number of moles of A and Nb be the number of moles of B, let us consider 2 components A and B in a solution. Let Na be the number of moles of A and Nb be the number of moles of B. Then mole fraction of a component is equal to the number of moles of the component divided by total number of moles of all the components. In example, in a binary solution containing 2 components A and B, if Na is equal to number of moles of A and Nb is equal to the number of moles of B, then mole fraction of A and B can be expressed as, mole fraction of A is equal to number of moles of A divided by total number of moles, that is Na plus Nb. Similarly, the mole fraction of B is equal to number of moles of B divided by total number of moles, that is Na plus Nb. So the sum of the mole fraction of the 2 components, when you are doing this one, that is equal to Na by Na plus Nb plus Nb by Na plus Nb. When you equate it, you will get as 1. The sum of the mole fractions will be equal to 1. So, or to find the mole fraction of a particular component, that is Xa is equal to 1 minus Xb, or Xb is equal to 1 minus Xa. For a solution containing I number of components, as if there are many components, then we have Xi is equal to Ni divided by the N1 plus N2 plus N3 and so on till Ni, or Xi is equal to Ni into the sum of the total number of moles, that is sigma Ni. It is easy to show that in a given solution, sum of the mole fractions of all components is equal to unity. That is, x1 plus x2 plus x3 all will be equal to 1. Example, there is the first problem coming up of mole fraction. Calculate the mole fraction of ethylene glycol in a solution containing 20% of C2H6O2 by mass. So you are asked to calculate the mole fraction of ethylene glycol. Assume that we have 100 grams of the solution, because it is 20% of ethylene glycol. So we assume that 100 grams of the solution. One can start with any amount of solution because the results obtained will be the same. Solution will contain 20 grams of ethanol and 80 grams of water, because 80 plus 20 together is 100. So it is 20 grams, meaning is 20 grams of ethanol is present in 80 grams of water. molar mass of ethylene glycol. You can calculate that is 12 into 2 plus 6 into 1 plus 16 into 2 would be, it is 12 into 2 plus 1 into that of hydrogen plus, there are 16 is for one atomic mass of one oxygen atom into 2 would be 62 grams per mole. The molar mass of ethylene glycol is 62 grams per mole. Moles of ethylene glycol. How can you calculate the moles? Mole is equal to mass by molar mass. So here it is 20 gram. The mass of ethylene glycol is 20 gram divided by the molar mass we have calculated just now. It is 62 grams per mole and the value is 0.322 moles. Moles of water. So similarly, for calculating the moles of water is mass of water divided by molar mass of water. It is mass of water is 80 grams divided by, we all know the molar mass of water is 18 grams per mole. See here also you can find that the units are written always. So according to the CBSE board, you have to write the units while substituting, and don't forget to do that. Answer here, the moles of water is 4.444 moles. So the mole fraction of ethylene glycol, we have learned the formula earlier. It is moles of that component. Here it is ethylene glycol, moles of ethylene glycol, the total number of moles. So we have calculated the moles of ethylene glycol and the moles of water also. The sum is moles of ethylene glycol plus the mole of water. It is moles of ethylene glycol we have calculated just now. It is 0.322 and the total number of moles, it is 0.322 plus 4.444 and the answer is 0.068. Similarly, we can calculate the mole fraction of water also. Mole fraction of water is moles of water divided by the total number of moles. And what is the mole of water that we have calculated here? It is moles of water is 4.444 divided by the total number of moles, that is 0.322 plus 4.444. You get the answer as 0.68. So mole fraction of water can also be calculated. Instead of doing by this method, we can also calculate it as 1 minus 0.068 because the sum of the mole fractions of the two components is equal to 1. So once we have calculated the mole fraction of ethanol, it will be easy to calculate the mole fraction of the other component, that is water also. You can calculate it by this method or you can write 1 minus 0.068. The answer will be the same. Next way of expressing concentration is molarity. This also we have learned in the 11th standard. It is the number of moles of the solute dissolved in 1 liter of the solution. 0.25 mole per liter solution of NaOH means that 0.25 mole of NaOH is dissolved in 1 liter. So molarity is designated as capital M. It is equal to number of moles of the solute divided by the volume of the solution in liters. Number of moles of the solute is equal to the mass divided by the molecular mass of the solute. That is the mass of the solute in grams divided by the molecular mass of the solute. That is equal to W2 by, that's capital M molarity is equal to W2 by M2 into the volume in liters. So M is equal to W2 by M2 into volume in liters. So for converting into liters, it is divided by 1000. So that is why the formula becomes W2 by M2 into 1000 by M2 into V. The unit of molarity is moles per liter. Next is an example, a problem. This type of problems we have also done in the 11th standard. The problem here is calculate the molarity of solution containing 5 gram of NaOH in 450 ml solution. So for molarity, as we know, it is the number of moles of the solute divided by the volume of the solution in liters. So first we have to calculate the number of moles of sodium hydroxide. To calculate the number of moles of sodium hydroxide, it is mass of sodium hydroxide, which is given as 5 grams, divided by the molar mass of sodium hydroxide is 40. That it is 23, that of sodium, 16, that of oxygen, and hydrogen is 1. So it is 5 by 40, it becomes 0.125 moles. And the volume of the solution in liters, the volume of the solution given in the question is 450 ml. So it is 450 ml, it has to be converted into liters, so it's divided by 1000. So molarity is equal to 0.125 mole of NaOH divided by, that is into 1000 for converting into 1000, divided by 450. 450 divided by 1000 goes to the numerator. That is equal to 0.278. So the next is, that is the answer to 0.278 moles per liter or 0.278 moles per decimeter. Next is molality. The next way of expressing concentration is molality. It is the number of moles of the solute dissolved per kg of the solvent. So this way of expressing also we have learned it last year. 1 mole per kg solution of KCl, potassium chloride, means that 1 mole of KCl is dissolved in 1 kg of the water. It is the mass of the solvent in kg. So molality, which is represented as small m, is equal to the number of moles of the solute divided by the mass of the solvent in kg. Unit is moles per kg. Number of moles of the solute, we know how to calculate it. It is the same as molarity. It is mass by molar mass. That is the same as capital M. Here it is not capital M, it is small m. It is same as molarity. W1 is the mass of the solvent in grams. So W2 by M2 is the number of moles of the solute. That is divided by W1, which is the mass of the solvent in grams, divided, but in order to convert it into kg, is divided by 1000, which goes to the numerator. The next is the problem based on molality. The first problem is calculate molality of 2.5 grams of ethanoic acid in 75 grams of benzene. So here the solute is ethanoic acid and the mass of ethanoic acid is 2.5 gram and the solvent is benzene, whose mass is 75 grams. We can do it. First, the molar mass of ethanoic acid is, we have to calculate it, it's 12 into 2. There are 2 atoms of carbon, 2 moles of carbon. 1 into, it would be 4 of hydrogen is there. It is 16 into 2. 2 atoms of oxygen is there. So the total molar mass is 60 grams per mole. Moles of ethanoic acid, mass by molar mass, means the mass of ethanoic acid is 2.5 grams divided by, we have calculated the molar mass, which is 60 grams per mole, and the answer number of moles of ethanoic acid is 0.0417. Mass of benzene in kg. The mass of the solvent is 75 grams benzene, so 75 divided by 1000, you get the answer in kg. 75 divided by 1000 is into 10 raised to minus 3. So molality is equal to number of moles of ethanoic acid divided by the mass of benzene in kg. Moles of benzene, moles of ethanoic acid divided by kg. Moles we have calculated, it is 0.417 into 1000 divided by 75. The mass of benzene is converted into kg, and that's why 1000 is there in the numerator, is equal to 0.556.